Good afternoon, everyone. Awake, asleep? Wide awake? How wide? This is one of the difficult sessions to take, and forgive me for my voice. I had a little sore throat early this morning, so I'm trying to work on it. I hope to get some good response from you guys before we really start. See, what I'm going to convey by way of this presentation is there's this one line that's been intriguing me and interesting me for quite some time. And before I start with my presentation, I would want your feedback on the one line that I speak. I tend to say, why invent when you can circumvent? And I somehow like this line really a lot. Why invent when you can circumvent? You can circumvent and you can patent whatever you have circumvented. Any other thoughts? पीछे वाले लोग बोलो यार जरा, हैं मस्त पीछे जाके सोने की तैयारी मत करो. So the backbenchers are supposed to be the most attentive ones, isn't it? That's how it used to be back when we were in college. How many of you have heard about this word patent circumvention? Quite a few hands. That's nice. That's really nice. And what's the first thought that comes to your mind when you listen to this word, patent circumvention? Tweak a little? Improving? Avoid? Non-infringement? Design around, okay. Okay. Okay, that's an interesting one. Fool around? Fool around with who? With yourself?
That's an interesting thing.
So yeah, I'm here to talk about patent circumvention, and it starts, the way I said, it starts with why invent when you can actually circumvent. Why do I say this? Because there's a people who are a part of R&D would appreciate that the life cycle of a product before it actually comes to market, there's a lot of research that has gone into it. There's a lot of effort that has already been made into it, already been put to bring that product to the market. There's a lot of research that has gone into it. And many a times what happens is, by the time, and there are a few examples that are there in the presentation, but then there's this one very interesting example that I keep talking about is, I belong to a filtration industry, okay. So we make filters. When I say we make filters for the auto industry. How many of you are conversant with the mechanical, a little bit of mechanical engineering? Just a little bit of. Because mechanical, I personally feel mechanical engineering is a relatively simple subject. It's relatively easy to comprehend and understand. So yeah. So these vehicles have a lot of filters that filter the input that's being given into the engine. Okay. And then the combustion happens within the engine, and then the exhaust comes out, the power is also generated. So whatever exhaust you see, there is a lot of impurity in the exhaust. So those impurities in the exhaust are not reduced by employing filters after the combustion chamber. So what the auto industry says is, the intake itself should be pure enough so that we don't get a lot of dirty exhaust. Okay. Now, when I start talking about purity, just to give you a little bit of vague idea of the kind of filtration efficiency that we are talking about, everybody knows that engine burns a mixture of air and fuel, right? fuel is filtered using fuel filters, air is filtered using air filters, and air filters already have an efficiency of about 99.96%. What more can you ask for? 100% virtually impossible, I would say. So, there are things that are done on the intake side to make the combustion even more purer. This is just setting up a brief stage on what we would talk about a little later during the examples. Now, why do I call this the mystic art of pattern circumvention? There is not one sure shot formula. Okay? And I've been doing this for what, about 7-8 years now. And in one of the case studies that I was doing, in one of the circumvention studies that I was doing just a few days ago, I found one more interesting way of doing it, which which has actually not been documented at a lot of places. There is this one formula that we generally follow for doing circumvention using TRIZ. TRIZ, this word you guys might have heard earlier today as well. Where did you guys hear this word earlier today? Bot TRIZ? Okay. So yeah, now that this guy is making bots for TRIZ, we also need to understand how do we use it, right? So we also need to understand what TRIZ is. How does it work? So why circumvent? Where does it all start? It all starts with a problem. There is a problem that's there and we want to solve the problem. That's where it all starts. There's a problem. What next? After the problem, there has to be a solution. Problem, solution, it's not that simple. If only it was that simple, life would have been much easier, hunky-dory. I had a problem, I have a solution, I use the solution, I just go ahead. But then, most of the times, I would say almost always, the first solution that comes to your mind is a patented solution. That's how we generally think. The first easiest solution that you would generally stumble upon would actually be something that somebody has already done and he or she has patented it as well. So what do we do next? What do we do next? I want you guys to answer. What do we do next? So see, this is going to do two things. I have a bad throat, so I'll have to speak less, and I'll keep you guys awake. So what do we do next? What now? Why not copy it? Unethical, huh? Actually, this is a very recent news article. US trade body puts India on priority watch list for IP rights violations. What next? Redesign? Redesign? How much work? Reverse engineering, somebody said. अभी भी तो वही किया था ना, reverse engineering कर रहे थे. So the problem with reverse engineering is, you want to say something? Okay. So the problem with reverse engineering is, there is a solution, the solution is patented, you reverse engineer it, you're going to end up making the same thing again. You're reverse engineering it only to understand how did he make it. See, the whole life cycle does not just end with finding the solution. There's something that's called as conceptualization, and then you actually make it, the realization of the concept. So if there is a solution that's already there, and even if it is not patented, even if you have to blatantly copy it, I have seen that being done quite a lot, even that is a lot of effort, frankly speaking. That itself, I mean, I give you a product and I tell you to copy it verbatim as it is. That itself is going to take about 2 to 3 months of time, at least. So now, if you are talking about redesigning, reverse engineering, how much time would this take? Quite a lot of time. And that's one point that I keep speaking about these days very often is, nowadays the life cycle of a product on the market is very short. How many years do you see one product being there in the market? 2 years, 3 years, 4, 5 years at the max. That's I'm kind of extending it quite a bit. Not more than 3 years. By the end of second, third year, you start seeing the next versions of it coming along. So do you really have that much amount of time to go back to the drawing boards, start designing it again? By the time you would have designed it, somebody else would have designed the next version of it, and you would always be lagging in the race. So maybe design around, circumvent. How many of you guys have a little bit of background of, or even a little bit of basic understanding of what TRIZ is? That's such a relief. Okay. So what TRIZ does is, it basically tells you to start looking at things from the perspective of function. What is the function that's being performed? So you break down a product or anything into multiple different components, and you identify the function of each of these components. So a product as such is going to have a function, and the components of the product are going to have functions which they perform on each other or on the various components. And interestingly, the best part about patents is, when we write claims, we write components. We describe components, we write the way they are connected to each other, and very often we also write what each of these is performing on the other component. So that way, if we start looking at, it becomes pretty simple for me to say, ki, if there is a methodology that talks the language of functions, and if there is a methodology that says that if there is one component performing a specific function, and I can tell you what else can do the same function, then probably there is a good chance that I would come out of the ambit of the claim that's been written. So when we start talking about function, I have an example that I use very often. This is my chashma example, or the spectacle example. Now this example is only for people who don't know TRIZ. Okay. So give me an answer as to what's the function of a spectacle or glasses. Okay. What else? Focal length. Good that we don't have a college crowd sitting. They would say that it's a fashion statement, isn't it? So what exactly does this thing do?
Vision correction.
Vision. See, I told that it's not for people who know TRIZ. Okay, vision correction, fine. Vision correction. Now there is one basic rule for functions in TRIZ. There is a function carrier, there is a function recipient. Okay. Function carrier is the one that is performing the function. Function recipient is the one on which the function is being performed. It might sound a little obscure, but then that's how it is. Can't be simplified any further. That's how I feel. And when the function carrier performs a function on the function recipient, it has to change at least one physical parameter of the function recipient. One physical parameter. So let's say vision correction, then who is the function carrier here, who is the function recipient here, and what physical parameter is being changed? Spectacle. What part of spectacle? The lens. Okay. Function recipient is the eyes. Okay. So what does it do to the eyes? कुछ गलत था सही कर दिया. कैसे? How? When? Okay, focal length वाले लोग, those people who are talking about focal length, tell me who is the function carrier and who is the function recipient? Lens of the eye. Okay. Is the recipient. Okay. Abhi now I'll add a little more twist. There's one more fundamental rule. Now the function carrier and the function recipient have to be physically in contact. Now tell me. Frame is carrier and glass is recipient. No, there's nothing to really laugh about. He's also right. But then that's a different function being carried out there. We are talking about the basic function. Focal length wale log. Who is the function carrier? Who is the function recipient? And what is the function? See, if you guys don't tell quickly, I have another 40 slides. I'll be stuck on this slide. Eating a lot of your time. इसके बाद तुम्हें चूहा भी पकड़ना है. क्या फोकल लेंथ वाले गायब ही हो गए क्या? इधर से कहीं से आवाज आई थी. बैक बेंचर्स, wake them up. Guys, post lunch, good food. थोड़ा ज्ञान भी ले लो यार. Okay, so what all is this glass coming in physical contact with? Light rays. So what does the glass do to the light rays? It is bending the light. That's what is actually being done. So this does not do vision correction. Vision correction happens as a function of light being bent by the glasses. Okay. So now we know this one thing, ki the whole story is about function. Okay. And then there are several components that are there as a part of one product. Those components have functions on each other. So we need to break it down that way. So when we are trying to circumvent, what we do is we first try to identify a patent that gives the solution. Then we decode the claims of the patent, build a function model based on the claims of the patent, and finally do circumvention. There are two case studies. Now I will ask your choice. There is one case study that's a little complex, just a little complex, not very complex, I promise. And there is another case study that's a lot simpler. What would you want to go through? And I'm not asking Kumar Anshu. Complex one. You guys are sport man. सोने के लिए तो नहीं बोल रहे हो ना. Complex वाला बताता रहेगा, I'll take a nap. Okay. So, I was talking about air being provided to the engine and reducing the emission. So, the problem here is to provide metered air to the engine to reduce emissions and maintain the stoichiometric ratio. ये थोड़ा tongue twister जैसा है, stoichiometric ratio. How many people know this term? Nobody? Okay. Stoichiometric ratio is nothing but a ratio of air and fuel that goes into the engine And if a perfect balance is maintained, there are chances of zero emission. Chances of zero emission. So, the idea is to maintain stoichiometric ratio that would ensure that emission is minimal. This is the problem, we have a solution. I will install a sensor that would read the amount of air being sucked in, and based on that I will change the amount of fuel being injected into the engine. Maintain ho gaya stoichiometric ratio. Simple as that. What were the constraints here? Because that's the world we live in. बिना constraints के कुछ होता नहीं है. It has to be located directly at the outlet of the air filter. Air filter is a device that generally filters air and provides the air to the filtered air to the engine. It needs a very streamlined or a laminar flow. Turbulent flow would not help. And the compressor should also get an output from the same port. Now, clean air in our vehicles are used at two places or multiple places, but then we need compressed clean air in the vehicle as well for certain specific purposes. So, there has to be clean air there is only one source, that's the air filter, but then it's going to be used at multiple locations, one the primary being the engine. Therefore, there is one more port that takes it to the compressor from where it's routed to the other ancillary components where it's needed. So, this was the constraint. Now, this is a solution, okay. I'll tell you what this is. ये डब्बा जो है, this thing is an air filter. This part is the outlet, this part being the inlet, and there is a filter element that's inside here. This what you see here is the mass airflow sensor, okay. And in this view I am not able to show, but then right behind it there is a port that provides the clean air to the compressor. Simple solution, doable, yes. सिर्फ एक डब्बा ही तो ऊपर बिठाना था. You just had to install one box on top of the existing air filter and you're done. But it was not that simple. See, when we first found this patent, we were like, fantastic, this is a US patent, we have to sell it in India. Not a problem. We were very happy that the 30-month time has also lapsed and we still don't see a publication, so probably we are safe. We'll build it, sell it. Everything done. When it comes for a final freedom to operate check, this appears from somewhere. One of the family members, Indian patent application. So now what? Now circumvent, simple as that. We have identified the patent. This is the patent. This is what the internal drawing of the patent is like. Inlet. This is the mass airflow sensor, and this space that you see is called the dead volume. Okay. Now, why is the dead volume needed there? Because remember, we needed an additional port to take the air to the compressor. Now, if I add this port right here at the outlet, the flow here would not be laminar anymore. And like we spoke about earlier, mass airflow sensor needs laminar flow, else it won't work. So, you create an additional box, let the air flow fill in here, suck the air from here for the compressor, then there is another tube here that would actually act as the outlet which feeds the engine. This is having perfectly laminar flow, and this is where you install the mass airflow sensor, and this is patented. So now you need to do something about it. So my engineering team comes to me and says, we want to copy this. Find me a way. So I was like, this is way too simple. And I mean, just by looking at it, even I don't know how are we really going to circumvent it, because there's no complex interaction that you see here. There is just one additional box that this guy has placed here. Looks like a very simple solution. So now we started drilling it down further. This was the claim, the boring dry part. I'll not drag you through this, except for telling you the main components, which we already spoke about. That there's this, the extraction device is what the dead volume is being called as, and then there is this sensor and the air intake outlet, the air outlet and the intake. Okay. Now you have to build a function model. Looks very complex, isn't it? So what we did is, we identified how many components were there in the claim. There was a filter housing which actually holds the filter element, air inlet, filter element, central volume is the empty space. So this thing does not seem to work. So this thing, I need you guys to understand a little bit. This area that you see, this white part, is an empty space that contains a lot of filtered air. This is where the filtered air is actually flowing from. This is the inlet, the air comes in from here. This is the filter element, the hashed part. Air goes inside, filtered air moves up further. So this whole area is containing filtered air, clean air. I want you guys to remember this. So clean air is also one of the components. And then this is something that's called as the interaction matrix, the first part of the function model, where we try to find out which component is interacting with which component, how exactly are they interacting to each other. And this is what the function model started looking like. So this was what was killing us, dead volume housing. Dead volume is the area, the box that was installed on top of the outlet, which was storing clean air, giving the supply of the clean air to the compressor and passing on the rest of the clean air to the engine. So this is something that we didn't need. So we have to get rid of this thing. This was the main claim element. Now if I get rid of this, what else goes? So it basically has interactions with the clean air, the filter outlet, the filter housing and the system outlet. So if this goes, this is going to have effect on these four things. How do we really go about it? I am ready to remove that, but then who is going to do the work of this guy? What was the basic work that it was performing? It was holding clean air, it contains clean air. So now when you start doing that, you start seeing who else does the same job. Clean air contains dead volume, clean air contains central volume. So there are at least two components that are doing the same function. So if I have to get rid of this guy, probably this guy can pitch in and say that, okay, I'll do the work of, I'm already doing the work of containing the clean air. Then I need to start looking at how do I use this guy to get my job done. Any ideas? We use something which can give the laminar flow right from the central volume. You're pretty much moving in the right direction. That's exactly what we did. We removed this. The function model started looking like this. And this is what the output was. There was a flow conditioner installed here. And the turbulent flow was because the outlet was being taken from right in here. We pushed the outlet further inside the clean space. the central volume. We pushed the outlet further inside the central volume. So by the time the air reaches here, along with the flow conditioner, the flow is again laminar, no issues, and you don't need that box over there. So you have reduced cost as well. You have reduced the complexity of the device as well, and you have achieved the result. I hope this was easy. Yes, it has been patented. So that's what I say, na. Why invent when you can circumvent? You circumvented and you invented, but you didn't invent. This is a patent on the circumvented concept. Yes, sir.
Honest, how is this any different than a redesign?
Oh, it's not.
That's a redesign.
It's not. No, wait. But the point is this:
It's a redesign.
I totally agree with you.
Okay.
I don't deny that. It's a redesign, but then if you actually go back to the organization and the way they function, or the way the organizations that I have been generally a part of, they function, when you start taking a redesign project, it starts right from scratch. Okay. Over here, the project did not start right from scratch. You had the solution, and you had an existing solution. You knew what exactly is it that needs to be done. Until then, you didn't know how you would achieve laminar flow at the outlet and the mass airflow sensor being integrated at the system outlet without being given a port being given to the compressor. Now that guy gave you an idea. He gave you an idea and said that, okay, if you distant the outlet of compressor from the outlet of the engine will still have a laminar flow. Now you just need to find out how do you distance it.
Oh, and that's great. I mean, this is a very powerful example of some very good techniques. It's also intentionally provocative. Circumvention is basically the same thing as efficient infringement, in a sense. So why don't you call it patent augmentation? Because that's what you've done. You've augmented an existing idea to make it more efficient and, in a sense, added novelty to it. And so, okay, sure, you can call it circumvention. I call it augmentation. I say we all exist on the shoulders of giants.
You have
There
given
is
me a better word.
nothing new under the sun. Everything has already been invented.
Right.
You've got all these cliches and you've just used available knowledge and technique to efficiently make it better.
Making it better or not, I knew that there's a solution and I knew that I needed the solution badly. Making it better happened as a part of trying to use that solution. And you've given me a better word, augmentation. So yeah.
But the working efficiency of both the systems are the same.
This is a little better. Yeah.
But that just happens to be better. I don't think that's always the
That was
case.
not the purpose of designing to make it
Right.
better. The
So-
purpose of designing was to
You just got
achieve
lucky
the
here. Yeah.
result.
You got very lucky here. That
Yeah,
it's actually
we got lucky here. I would say
you
that.
said you saved money on the design and you also circumvented. But I think a lot of times when you're trying to circumvent, that might not be the case, right? It might not be more elegant. It might
Right,
be
right.
more complex and maybe more expensive to. So it's not always augmentation necessarily. Sometimes I think maybe it is just circumvention, and you haven't actually gotten a better product, but you have circumvented the patent.
Yeah, because that's what you actually need at the end of the day. You need a working design which was patented, but then you just want to somehow cut the corners, come out of the patent scope.
Is it like, can we have the risk of doctrine of equivalence improvement?
No.
Same one.
Where would doctrine of equivalence come into picture? Now we start treading into patent laws, okay. Another very interesting area. See, I can see where you are coming from because that is what my thought process was when I actually got introduced to circumvention. Okay. Now where does doctrine of equivalence really kick in? If the claim is broad enough,
I think ma'am's question has the answer. She was asking it exactly does the same function. I don't find any difference in drastic difference in the performance of these two minor changes.
performance is something that we have not discussed yet. Performance is something that I can show when I start giving you the test results. Function, it's doing the same. I don't deny that at all.
Yes.
Now, talking about equivalence, equivalence comes to picture when you start looking at the claim construction and what all has the claim covered. The claim had a specific component called the extraction device. Where do you find it here? If we can go back to the claim, good that the audience has woken up. I like it. Now, read the claim. This was a little dry part, so I ran through it.
Just a
read the
question.
post-characterized part. That's how claims are filed here in India and prosecuted. Two part. Characterized in that the extraction device is arranged downstream of an air filter. Now, there is a specific extraction device that's there. Now, where do you find that extraction device in the design that I have shown?
Even though I think it's an annular movement of that air, right?
Annular movement of the air?
Laminar.
Laminar flow. Where do you find the extraction device? Tell me.
So just a question here.
Huh?
Yes.
From a drafter's point of view.
From
a drafter's point of view.
drafter's point of view.
Yeah.
Yes.
So a drafter would have drafted a narrow claim if there are a lot of prior arts already existing. The way the claim looks, it's quite narrow. So there are a lot of terms there. So when you did this activity, there would be a prior art that already exists that the drafter is trying to get out of. So then you run a risk into getting into that particular thing. How did you
see,
work with
of
that?
course, when I'm doing this, I must have done my study really well. Okay, those patents, I mean, whatever patents that he was trying to overcome for drafting such a narrow claim, were none of those that would have actually caused any harm to me.
I'll just
And
add
from
up.
a drafter's perspective, just to tell you, this is a topic that I was discussing yesterday in one of the conferences. It's very simple mathematics. Your mistake and I'll capitalize. You make one mistake while drafting, and people generally don't think through when they are drafting applications. You have to think through a horizon of 20 years. To chhod do, 20 years is too far because nothing lasts for 20 years these days. But at least you need to think through the horizon of about 10 years. And you need to start thinking, put on a thief's cap and understand how somebody would like to, steal my idea. Which not a lot of people do, frankly speaking.
So,
May I
I'll
ask a
just,
question?
I'll just add up one thing that these two things are completely separate: patentability and infringement.
Huh?
So patentability is one issue and infringement is completely different issue. If you just go back to the claim, no? Would you mind? Yeah.
No, not at all.
Yeah, see, after that bracket 8, it is written that characterized in that.
Huh?
So the characterized in that gives the improvement over the prior art. So you
Right.
need to see the prior art, what was the prior art, and what is the improvement claimed in this particular patent.
So you are talking
in
about the
this
two-part
prior
claim. The pre-characterized part is what
Yes.
forms the prior art, and the
That is the-
post-characterized part is what the invention
Right.
is.
So if that characterized part, that extraction device performs the inventive step of this particular patent, and if you remove it, then the question of infringement becomes very, slim
Right.
automatically by doctrine of equivalence. Okay, have you got the point? So if you, when you check the doctrine of equivalence, certain things you need to consider. What was the prior art? Why that invention was carried out? And then whether it is the function, way and result test is satisfying or not. So you need to consider in view of that particular prior art. So in this case, prior art is of this patent's prior art, where they have invented over this extraction device. And while designing around, you are removing that extraction device per se. There are a lot of many things to be checked, that prosecution history, the whatever.
Hope this is the original claim, right?
Yeah, this is original.
Original claim.
Thank you very much. You actually helped me a lot. I have a bad throat as it is.
Sir, I
You
have a
actually
question.
helped me answer the question. Thank you.
Actually, one part of the question that I had, you have already answered, and that was whether it's a possibility that the new device that you have, it's a possibility that it is also a subject matter of an independent patent, but you already answered that question that you have done your homework.
Of course,
But I give a very practical example which I faced years back. I'm from Unilever, so I don't deal with such complex inventions. My inventions are usually about compositions. So
They are much more complex.
I had a toothpaste case.
Okay.
And in the toothpaste case, there were, so in your mechanical devices, you have elements and feature, function, position. In toothpaste or in compositions, you have ingredients.
Right.
So there were ingredients A, B, C, and then there was one ingredient which was a characterized portion, and it was written that it must have a RD or a dentin abrasion of less than some value. So then we were looking at the so-called design around principle, that if it is written less than so and such value, fine, we just replace that ingredient with something which is more than, right? So that's a natural discussion
Tendency,
or
yeah.
tendency to do that. But when we found after some time, we did another search and we found that the same patentee had filed another patent on the same day where he had that RDA of more than that value. So there's one patent less than, there's one patent more than.
So he was fencing it properly. Fencing it properly. One more?
Yeah, one more. Just one more point. Actually, just I would like to add up here also one thing. When it comes to patentability and the competition, then if you file this invention as a patenting, a new patent, the obviousness question will again be raised, most likely. And then to avoid that, to overcome that obviousness objection, one needs to demonstrate that how superior is your invention is over the existing art. So there lies the question whether by removing that dump,
Dead volume.
what is the improvement you have actually done? Yes.
Why would I even show that as a prior art for my invention?
No.
And that would not come as a prior art at all, for that matter.
No.
Anybody who searches for
The
this is
question
not going to
that
find a dead volume.
You will show in the prior art description section itself. But the question examiner will ask that what is the material difference it causes? And what is the superior effect it gives?
No, that question is never going to come. Just for information, the examination has already started and I have received the FAR. Just to answer your question, what is it that I would have claimed here? Right now you are able to connect this to the previous application because I have shown you. If I had not shown you that, you would never be able to connect this to that.
That is the job of the examiner to find out what
नहीं
is
मिलेगा
there.
ना, connect ही नहीं होगा. What is it that I am claiming here? I am not claiming a dead volume. I am not claiming an extraction device. I am not claiming a device for locating the mass airflow sensor.
Yes,
He will only do search based on whatever claim I have done. He will never find that patent. And when I have drafted it and I knew such a thing would happen, I would make sure that I don't draft it that way.
Yeah, then you need to demonstrate what is the closest prior art, and you need not show this was the closest prior art. Got the point? The departure has to be demonstrated against the closest prior art. So either you establish it or let the examiner establish it.
That's what we do, na? We establish the closest prior art based on our comfort.
No, but
Well, that's what we know. That's a fact. That's a fact. That's what we do always. That's what we do always. And that's what examiners also do. They very often will, in US they would give you a 1 or 2 rejection. In India they would give you a novelty rejection saying that there is no novelty. So that you go back and say, no, whatever you have cited is wrong. This is what my novelty is. So you come out and say that, okay, this is what my novelty is. Now he starts searching only on those 3 parts. So he's reducing his job. That's what he's trying to do, and what we are trying to do is we are trying to locate it to the best prior art which we think we will be in a best position to defend.
so actually they are not cross-checking the obviousness part. Then.
No, they do cross-check the obvious.
That's the
That does happen. That does happen. How would you say that obviousness is not checked during examination? That would definitely happen. Do we have time for one more case study, or? I had put the timer to 55 minutes just before I started, okay? I still have 10 minutes, 17 seconds. So see, that's what the idea was.
Keep it like interactive, then.
Yeah. So this is a much easier example. What was the problem? The problem was to catch a mouse. As usual, the constraints. The mouse must not die. I want the mouse alive. And I should catch it in such a fashion that I should be in a position to release it wherever I want. So I will collect 100 mouses, and if you guys start sleeping in my session, I'll release them all here. And this is the solution. A very sophisticated mousetrap. I'm so sure किसी ने देखा नहीं होगा. Nobody would have seen such a sophisticated mousetrap. This is the subject matter of a US granted patent. A patent that was granted 1 year ago. A US granted patent granted 1 year ago. If I have, so what happens here is, I'm sorry. Switch it off. So what happens here is, there's a light beam that's here. This is the place for the mouse to enter. Whatever you keep inside, cheese, bread, whatever you want to keep, whatever that would attract a mouse, the mouse goes inside. As soon as the beam interrupts, there's a shutter that closes this door. Now the mouse is caught inside, and then it has a regular spring-loaded arm that catches and holds the mouse, stops it from moving anywhere inside. Okay. But this is very sophisticated. It does not work on regular key. Mouse has to jump on the spring-loaded part, then only the spring-loaded thing gets activated. The moment it goes inside, the stuff gets activated, it closes the door, catches the mouse. Whether the mouse wants to eat the cheese or not is not the question. We are not checking the greed of the mouse. We just want to see that it goes inside and it never comes out, unless we want it to come out.
What happens when you keep the food inside? The doors will be closed.
No, you don't activate it. You see there is a plug here. You have to switch it on. It does not work automatically. So the idea was to make a much simpler mousetrap. Abhi generally the mousetraps that we have seen, where very often the mouse dies. Okay. And apart from killing a mouse, there's a very foul smell that creates further more issues than a mouse running around. Okay. So we found this patent. We did, as usual, we read the interaction matrix and we considered mouse, which was not a part of the claim. Still we considered the mouse here because mouse is what is interacting with everything. Mouse is what is interacting with the walls, with the floor, the opening, it gets inside through the opening, the trap holds the mouse basically. And there's a latch and a solenoid. The latch is connected to the solenoid, so as soon as the mouse enters and the light beam is interrupted, it sends a signal to the solenoid, which sends a signal to the latch, and it holds the mouse, closes the shutter. Kahani khatam. Now you want a device that is very simple, should not use electricity, but it should not close when you're trying to put the food inside. That's one constraint that I now add. Should keep the mouse alive even when it is inside. And I should be in a position to release it. Now this is what the function model looks like. Cheese or food item, trap, floor, mouse, there is this enclosure, the electronic eye through which the light beam is coming out, which is being interrupted, and then it activates the solenoid, the openings, the latch. Okay. Start trying to do circumvention. We say that, what if there is no trap? Catch the mouse without the trap. We don't want to consume electricity, no electronic eye. No electronic eye connected to the solenoid, no solenoid. Trap bhi gaya. If you remove this, this goes. If you remove this, this goes. What are you left with? So now how are you going to hold the mouse? Now you're left with the enclosure, the floor, the walls, the opening through which of course the mouse gets inside. Now you have these parts that you have to stay with and make sure that the mouse is caught inside. What may be the solution? Huh? Huh? Huh?
Okay, so any mechanical movement by mouse while going inside can shut that trap, shut that flap.
Huh?
Then
Okay.
that
What
we
can
need
be?
to work on.
There can be several mechanical movements.
Yeah, any spring
Right.
loaded or any movement when mouse itself goes inside.
But we have to remember that mouse has, we don't have to kill the mouse. We have to remember that also.
Yeah.
We can have a spring loaded thing like the Purana wala mouse trap.
Yeah, the interior will be the same. Only in Purana wala mouse, what happens that when the mouse actually eats the cheese, then it closes, right?
Right.
But in this way, when it itself enters into the trap, the flap reduces. So, we
So
need
as
to work
soon
on,
as it enters, it has to close.
yeah, and we need to work on that mechanism. And it would be mechanical because its electronic parts are not there.
Yes.
Yeah,
A purely mechanical
yeah.
device where the trap closes as soon as the mouse enters. We came up with this. Now, you see the bend here. As soon as the mouse goes inside, the mouse is gone inside, it turns upside down. Saw the cheese, got inside. As soon as it gets inside, upside down. And the flap that you see here is the door. The door is closed. No mechanism anywhere. Let the mouse come in, I'm waiting. So the mouse has to be really slim on diet to ensure that it does not close. Yes?
One purpose which you said that it should not die also, right?
Yeah.
So is there any air filtration coming in, like something that, you know?
Now I'm not going to keep it inside for a very long time.
We can have some small kind of
We can have.
something.
We can have that. And then you can release it. Probably inside here when you guys are sleeping. So yeah, this is how it happens. 1, 2, gone. Done and dusted. So this is one of the 11 ways of pattern circumvention basically that we saw today. There are another 10 different methodologies available. I think I don't need to ask for question and answer because we have had enough of it during the session itself. Thank you for being an attentive audience post lunch. And if I don't think there would be any more questions. Are there any? No, good enough. Okay, Gargi, thank you.